Okay, friends, on behalf of Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur, I'd like to welcome you all in this mega webinar series. We are conducting since the 13th of March, and today is the 8th week. And this Center of Excellence is a 3-year-old, and we are working along with the industries for giving solutions to the industrial problems. We are also organizing training programs for this, the industry, the people, MSMEs, and then startups. We are working with 6 industries, out of which 4 are the private sector and 2 are the public sector. Under this Center of Excellence in Advanced Manufacturing, we are organizing this, the webinar on various, the topics of advanced manufacturing. We are covering the areas of artificial intelligence. We are covering the areas of the additive manufacturing, manufacturing process modeling, Industry 4.0. So basically all digital, the methodologies. Now today, we do have with us Professor Shuvra from the University of Detroit, Mercy in the USA. And before I, talk about, before I introduce Professor Das, I'd like to talk about the topic today. All of us, we know that we are standing in the era of Industry 4.0. Industry 4.0 does encompass a lot of digital technologies. Now at this, the advancing technologies, we are all, facing a real true question, that is how much we are equipped. What sort of education is required to take the Industry 4.0 forward? Specifically for the industry, how much understanding of the STEM, science, technology, engineering, mathematics knowledge is required? Is there any need of Industry 4.0, education 4.0 to take the Industry 4.0 forward? So all this, the thing we'd like to hear from Professor Shuvra Das. Professor Das has done BTech from IIT Kharagpur and then Masters and PhD from Iowa State University. He was a postdoctoral researcher at University of Notre Dame and worked in industry for several years prior to joining the University of Detroit Mercy in 1994. Presently, he is a professor in mechanical engineering at that university. Professor Das' research area are the modeling and simulation of multi-physics problems in manufacturing, and also he has the expertise on the promoting the engineering education. He has worked in areas ranging from mechatronic system simulation to multi-physics problem simulations using CAE tools such as finite elements and boundary elements. He has authored or co-authored 5 books on these topics. He has also served the university at different, the positions. So with this, I'd like to, invite Professor Shuvra Das to talk about this, the wonderful concept that does Industry 4.0 needs the education 4.0. Professor Das.
Thank you very much, Professor Pal, for the kind introduction, and thank you very much for inviting me to talk to the audience here. It is rather exciting to talk to people who are organized by my alma mater. So I'm always very fond of going back to Kharagpur, whether physically or virtually. So let me make sure that I'll share the screen right now, and I'll turn off my video so that my Wi-Fi is not overtaxed. And then when we are done, I'll turn back the video and also for question, answer, and discussion. So I'll share the screen first. Let me stop my video first. Okay. Oops. Can you all see the presentation?
Yeah. Please go to the full screen mode. Yeah.
Yeah, I'm going. Okay. So
Yeah.
I'm now in full screen mode. Again, thank you for the invitation. My topic today is does Industry 4.0 need Education 4.0? And I have been, since your invitation and since the presentations from the last few weeks, I've been going back and looking at some of the excellent talks that have been delivered here. And I looked at the topics that are coming up. So I can confidently say that this topic is somewhat different from all that topics, because they're focused very much on specific research topics and applications of technology. I do not claim to give you any answers. I hope to raise a lot of questions through my presentation here. So this is more of a food for thought for the audience. But before I get into the actual presentation of this topic, I want to say a few words about my journey. I grew up in Howrah, in a very industrial area of Howrah. And there were about 9 or 10 foundries in the road on which my house was. And one of them was, we had a family business in engineering. So, from my childhood, I would observe, cupolas and metal casting happening every week. So fairly early in my life, I was drawn towards mechanical engineering and almost knew that is what I would like to do. And of course, I studied at IIT Kharagpur and finished my BTech in 1985. And I still consider those 4 years as the best 4 years in my life. And I know a lot of my friends feel the same way, particularly not as much as because of what was happening in the classroom, but particularly because of the peers. One of the biggest gifts of IIT systems or IIT Kharagpur is the bringing together of people with diverse background, diverse viewpoints, diverse understanding, very smart people. And I consider I have benefited a lot in my life because of that connection. Of course, there were very, very excellent experiences in the classroom as well. And I would be remiss not to mention at least 3 inspirational teachers that I still look very fondly upon. Professor B.G. Ghosh, who used to teach us, solid mechanics and several courses in solid mechanics. I was particularly inspired by him. Professor A.B. Chattopadhyay, who many of you know, was a stalwart in manufacturing, very inspirational. And Professor Amolendu Mukherjee, who taught us systems controls, bond graphs, etc. So I considered them very inspirational from my viewpoint. And it was because of Professor B.G. Ghosh's class that when I first started my career in research, I was drawn towards, structural mechanics problems. That's where I started. And then slowly I transitioned into, my interest in multi-physics problems, into modeling simulation of different manufacturing processes such as welding, casting, metal forming, EDM, laser forming, etc. So I spent many years working on those. And then around late 90s, in conversation with some of my colleagues in electrical engineering, I got interested in the world of mechatronics. And that's where I started collaborating with them. And it led to many research activities, curriculum. And then in 2010, we started a new undergraduate major in my university, mostly through my spearheading in robotics and mechatronic systems engineering, which was sort of a combination between electrical and mechanical. And that's when I went and relearned bond graph that I learned from Dr. Amolendu Mukherjee and subsequently wrote textbooks, etc. So it's an arc going through going through different areas, and I still go back and look at the three people I named as my inspiration. Lately, I've been very interested in educational reform, and I look at it as a big picture problem. It's an enormous size problem, and that's what our talk is here today. Trying to advance. Before I get into the meat of the talk, I just want to recap a little bit about the geography. Of course, I'm from India, from Howrah in West Bengal, and I currently live outside of the city of Detroit. Just so you know, that's locally it's called Southeastern Michigan. It is a particularly important industrial area in the United States because it is the hub of the automotive industry in the United States, therefore a hub of large manufacturing facilities as well. And one of the largest or one of the places with the highest concentration of engineers in the United States. Now, in my presentation, I'm going to make statements at different points about educational systems, but I want to acknowledge that there are gaps in my understanding, particularly as far as India is concerned, because I've never worked in India. I know the educational system from a distance, being part of it, but of course, there are gaps in my understanding. So with that, here is the outline of my presentation, a brief introduction about Industry 4.0, what we call Education 4.0, some snippets of our work on characteristics of the workforce, characteristics of Education 4.0, and then, what are the challenges and some examples of things people are doing which are sort of, successful, and then a few words of conclusion. As I said, I expect to raise more questions than give you answers. In fact, I don't necessarily have a good answer myself. I'm still looking. So with that, Industry 4.0, this audience knows enough about it to know that it's sort of, 4.0 means that there is a 1.0, 2.0, 3.0, the first three industrial revolutions, and we are living in the fourth industrial revolution. Industry 1.0 is associated with the discovery of the steam power and the steam engine in the 1780s, which led to enormous change in the mobility of the people and availability of sources of mechanical energy. Around the early 1900s, the second industrial revolution is associated with, the Henry Ford and his manufacturing systems of, automobiles. It was marked by repeatability, efficiency, affordability, and high volume manufacturing. The Industry 3.0, which is around the 1970s, was to make these processes more efficient through the use of new technologies such as automation and computerization. And Industry 4.0 is what we are living through, where these machines of operation are getting connected through wireless technology. So that is sort of the pathway for the four industrial revolutions, and you are all familiar with that. It is important to look at the transition times of these. Going from 1.0 to 2.0, it took a century and a half. From 2.0 to 3.0, it was happening over like 6 decades or 7 decades. Between 3.0 and 4.0, which we are currently living in, it was a fewer number of decades, maybe 2 decades or 2.5 decades. However, the current pace of technology change is exponential. We know technology is changing every day. It is changing at a very fast rate, and things that are brand new today may become obsolete in a few years. So that is the new thing that is associated with the last 20 years or in Industry 4.0. That was not the case in the prior industrial revolutions. Now, if we may, sort of map the education education, pathway with the timeline of industry, the Industrial Revolution, we can go back and see in the 1780s, education was not a big deal. Child labor was of the order of the day. People did not need to get education to earn a living. And education was confined mostly to the luxury of elites and the rich people. So people who didn't have to worry about earning a living were, trying to learn how the earth moves and looking at the sun and looking at the planets and looking at the world and thinking deeply of how things work. However, the current educational system has its roots in the world of Industry 2.0, where repeatability, uniformity, efficiency, and mass production was the order of the day. The education system actually evolved to be something like that. If you think of the current educational system or the engineering education system, it is meant to create lots of people who are similar to each other, because we have a standard curriculum, we have a standard procedure. It's highly linear. It's highly linear, and you go from one prerequisite to the next course and the next prerequisite to the next course. So it is designed after after the automated manufacturing system. There is quality control and all those things. So this is what evolved out of Education 2.0. Education 3.0 did not change, did not have any paradigm shift in the education. Just like, manufacturing processes became more efficient in the third industrial revolution. Instead of using, log tables and slide rules, we started using calculators. Instead of drawing on a board, we started using CAD. So the tools became more efficient, but there was no paradigm shift. The question comes in, do we need a paradigm shift in this current world in Education 4.0? So we are calling it Education 4.0 to go with hand in hand with Industry 4.0. So in this current times, do we need a different paradigm? Do we need to think differently? So I'll throw out a few quotes and some data here. This is a very famous quote by former US Secretary of Education, Richard Riley, who said, we are currently preparing for jobs that do not exist, using technologies that haven't been invented in order to solve problems we don't even know are problems yet. So that kind of captures the uncertainty of the world that we are getting in. This statement was made in the late 90s. He was the education secretary of President Clinton. Here is a quote from a publication. It says that many jobs, such as social media manager, blogger, app designer, app developer, big data analyst, they seem quite conventional to us today. However, they did not exist 10 years ago. And purely digital jobs are not purely digital either. You need to have a knowledge of the field of application as well. These quotes and the data, some of the data that I'm going to show now, are indicative of the current times. These are quotes from actual research. It says 65% of children entering elementary school this year will work in a job that do not exist, that haven't been invented yet. 49% of current jobs have potential for machine replacement. 80% of the skills trained in the last 50 years can now be outperformed by machines. And you see the trend, which basically is saying, like, we are training people. We are very fixated on, this has to be the curriculum, but we know the future is very uncertain, in the sense that we don't know exactly what their future will be. In fact, there is indication here that there is a lot of research around the future of work, and people are worried that there won't be enough work or enough jobs for people, for the world population. So the concepts such as universal basic income is starting to be mainstream. In fact, in the last presidential election in the US, there was a very well-known candidate, who didn't finally make it to being the presidential candidate, who had a platform on universal basic income. I mean, his proposal was to give $1,000 a month to everyone. So those kind of ideas are becoming mainstream. I have been following, the recent elections in India as well, and I saw there were different political parties were essentially putting up those kinds of ideas, and then go back into this concept of universal basic income. So, the bottom line is, this is the future. This is the current time. Here is some data, two interesting snippets of data about Southeast Michigan. The first one says that 30% of the middle skill labor pool will be displaced by automation by 2030. Okay, so automation will make things more efficient, labor pool, people gets displaced. The second line says there will also continue to be a shortage of workers with the skills industry is seeking. So if you look at those two things together, a lot of people will be displaced, lose jobs. At the same time, there will be jobs that they won't be able to fill. Okay, so that points to the fact that we need to train people with the right skills. Okay, it's not that there won't be jobs. It's like there won't be jobs which require a certain skills that people won't have. And that the third sentence is also important, which says that we will stop making people doing specific tasks. People will be expected to do multi-track careers. So a mechanical engineer may also need to do data analysis and network administrator, for example. Here is a scary piece of data about India, and this is from many different publications. I've seen similar data. The scary part is this quote, the second quote, about 94% of Indian engineers are not employable. Okay, and those who are in India can speak for this. They may have their own opinion, but obviously I hope they're not talking about IIT engineers, because large percent of Indian engineers are actually coming from the large number of engineering colleges and universities that have grown up in the last 20, 30 years. Many of them are private institutions, and the claims in these articles are that these are the quality is lacking, or is not high, or etc. But the bottom line is, if 94% of Indian engineers are not employable, what is happening here? Okay, what is happening here? And this is in terms of the 4-year engineering degree. We're not talking about master's or PhD, which is a very different ballgame altogether. But this is the bulk of the engineering graduates who are graduating in India. So obviously, this is a worldwide question. Its nature is different in India. Its nature is different in the United States. But this is a worldwide question which needs some attention from the entire community that is involved in educating engineers. So here, in this next section, I'm going to talk a little bit about a part of our research. There's more to this, but I won't get into a whole lot. But just to give you a snippet of information. So I work with some social scientists whose background is in sociology and economics, etc. And we use a tool called TTI Trimetrics, DNA analysis. This basically looks at people's motivators and behavioral styles. Two broad areas: what drives them, what is their motivation, and what is their work style, or what is their learning style. And it uses 25 areas of one's personal, professional competencies. But I'm not getting into the detail of the process, but I want to share a few results out of this, which is important, or which is kind of interesting. First of all, the workforce is made up of many generations. Okay, currently there is like 4 generations, or maybe 5 generations that are in the workforce. So if you think of the baby boomers, these are terms very common in the US, like so the ages or their birth times are given here. Baby boomers, Generation X, millennials, and Generation Zs. Generation Zs are the ones who are getting in the workforce right now. There is a huge difference in the working style, in their attitude, in their use of technology, in amongst these people. So people from our generation, for them, they need to go to the office to work. Okay, they go to work. Okay, so home and work are 2 separate places. They spend a lot of time in workplace. So there is a home life imbalance thing. In comparison, the current generation, because of their proficiency in use of technology, there is no barrier between work and life. They can work from anywhere. They can live the life for anywhere. But also they are very particular about work-life balance, which previous generation people did not have a good sense or good behavior about work-life balance. The use of technology and proficiency in it is also very, very different in these generations. So these are different generations with different skills and attitude, all in the same place. More so in the educational context, we as educators are from a different generation from the current generation. So if I want to learn something new, I will go and look for a text, an authentic material that somebody has written to look that information up. My students hardly ever open a textbook. They go to the YouTube videos that somebody has put up and to learn how to do it. I mean, I'll give you a quick example. My daughter, who has grown up here, never learned to wear a sari, or for obvious reasons. But one time she wanted to, and we were not, my wife was not at home, so there was no. So she, when we came back, she used a YouTube video, learned to wear a sari, and had worn a sari. Okay, so that's where they naturally gravitate towards. Just a quick example to show you that. What we also did is we ran this TTI matrix on 3 different groups. This is a separate part of the research. 3 different groups: the next generation leaders who are engineers already, but they are new to the industry. They're younger members in the industry, so they're practicing engineers. The next generation engineers, these are students in engineering programs, and the next generation of skilled trades, which are technicians. They get 2 years degree, they work as technicians, mechanics, etc. And I'll quickly show you some charts and point out some important conclusions here. So this is the behavioral pattern of these 3 groups compared with the TTI mean. And if you look at the blue line, the blue line here represents the next generation of leaders, which are, new employees or fairly younger employees, but they are expected to be leaders in the industry. So 2 things: they're bad about being collaborative, and they're good about being commanding. Okay, so this is an average over a fairly large data set. So whereas in engineering, we emphasize on teamwork and we do team projects, etc. But obviously, we are doing a bad job at teaching collaborative behavior among these people if they are collectively not being collaborating and being commanding. Similarly, here is data about competencies of, look at the red line here. The red line actually has worse scores among all of them. The red line is the next generation of engineers. So these are students in the engineering program. And basically what the conclusion is that entering freshmen are poorly prepared. They lack competency in almost every category. Okay. So this kind of data tells us a lot about individuals' learning, individuals' preparation, what kind of raw material we are getting into the engineering work or engineering programs, and how we can use this data to inform us and help us make changes so that we can serve this population. So, there's more to this work, but I'm not going to delve into that. We are going to get into the Education 4.0 discussion from here. I've set the stage about all this background information. So what is Education 4.0? So there's no simple answer to this. But if you look back, or if you review literature, since about 2000, there has been many organizations who have been coming up with reports, studies about what should be the future of engineering education. There is an extensive study done by American Society of Engineering Education and the National Science Foundation on knowledge, skills, abilities, etc., that are required for the future of the future workforce. So it's a multi-year study in 4 parts. Then there are, education and vision of education report from the World Economic Forum, jobs report. There's a study out of European Union called Universities of the Future. So in this next slide, I have captured the summary out of 3 of these, the 2, World Economic Forum reports in the first 2 columns, and then the ASWTUE study. I'm not going to read through all of these because this is a busy slide, but I want to point out what are some of the characteristics that they're looking for that would be the outcome of the engineering education: good communication skills, physical and engineering science fundamentals, ability to identify, formulate, solve problems, systems integration, curiosity, self-driven motivation, economics, and you can read through the list. The question is, does our current education system do this for most students, who go through a 4-year program? So that is a question we have to ask ourselves. Are we doing a good job of critical thinking? Are we doing a good job of willingness to take calculated risk? Ability to prioritize efficiently, self-driven and motivation, systems integration. Are we doing a good job of this? That's a question all of us need to ask ourselves. I have asked myself, and I have my own answer. But these are the characteristics that are necessary for the workforce. And using all this information, one can come up with, 8, 9 characteristics for this education system to meet those characteristics of the output of the education system. So this previous slide, the previous table was, what would be the output of the education system, as in graduated engineers? And this is what should be the characteristics of the system in order to meet those outcomes. So I'll talk a little bit about each one of these, starting from the top. Flexible mode of individualist learning. In today's day and age, there are, individuals, we know that individuals' learning styles are different. Some students learn by doing. Others have to sit, listen to a lecture, understand everything to the last minute before they try to do anything. Those are 2 different learning styles. However, we are putting all of them in an overwhelmingly large number of lecture classes and putting all of them in through the same system of learning, even though right now we have these tools in our hand, flexible mode of individualized learning. If left up to them, they will gravitate towards their own, best learning approach. But we are putting them through a system because the system was set up many years ago. Flexible source of knowledge and information. I talked about earlier about, YouTube videos. We all know that, online curriculum is now, ubiquitous. Like you have organizations such as Udemy or Coursera or edX who have very high quality, videos. I know Indian institutions are putting out lecture videos on many different topics. So information is all around us. You think of how we designed our current educational system. We expected the information to be coming from one source in the classroom, whereas in reality, the information is available freely and from many different sources. So it has to come from many different sources. One particular thing that I'm particularly passionate about is this formative assessment of skill rather than the way we assess skills. Our mode of assessment is mostly end of semester exams, which is not the best way of assessing skills. We are assessing ability to memorize and regurgitate, but we are not necessarily assessing skills. So we have to think about formative assessment of skills. We have to focus on acquiring skills rather than knowledge. Remember that quote from a publication which says 94% of graduating engineers are not skilled for the workforce. We have to focus on acquiring skills rather than knowledge. The teacher has to be a mentor and a coach rather than the source of information. Now, in olden days, when information was all directed through the teacher and through textbooks, people had to look at the teacher and knowledge was emanating from the teacher to the students. However, things are different right now. Teacher has to be a mentor and a coach rather than a source of information. Just-in-time information based rather than prerequisite based. This is also something I'm very passionate about, is that most of what we learn in lecture classes, we forget by the time the next semester comes around. People, if they're honest, they will agree to this. It is only when you use it or when you try to teach to somebody else that you actually learn things. Okay, so we have to focus more on just-in-time learning. When you need the thing, how can you learn? Or when you need the thing, how do you learn and use it? And that leads to the experiential or the hands-on part. Like, how do you apply it? Or do you have to be able to apply it? It needs to be transdisciplinary. And very, very important, many of these first 8 things can be done in smaller sizes, in small groups. But if you are successful in doing them in small groups, how do you scale it? How do you scale it to large groups of 100 people, 200 people, 300 people, 1,000 people? So these are important questions that I don't have answers for, but these are people agree that these ought to be the characteristics of Education 4.0 or the new education system. So with that, I'm going to move on and talk about the challenges. If we agree that some of those characteristics have to come in our education system, what are some of the challenges that we are facing? And in order to talk about the challenges, I'll talk about education ecosystem, which really consists of 3 distinct parts. One is students or raw material that are coming into the education system. So these are students who are finishing, class 12 or high school and then getting into the academic ecosystem. The second is the academic ecosystem, which is what we do in a 4-year program. And then the third is in the industry 4.0 skilled workforce, which are going out as the output of the system and going to the workforce. So let's talk about the pre-college zone. And we looked at many different aspects of the pre-college zone, but I'll focus on two things, which this is a little more US focused, but I'm going to draw some parallels in the context of India. Students unprepared in certain key areas. This is a very critical thing. In the US context, it's mathematics and physics. If you look in literature, students are not well prepared in math and physics who are coming out of US high school going into college. You'll hear more about the mathematics, but the problem is actually more severe for physics. Only about 40% of high school students in the US graduates with a single course in physics. Okay, only 40%, so 60% don't get any course in physics. Some parts of the country have 80% students studying physics. Other there's as low as 10 to 20%. Now, where there is low, those are typically low income, minority population, colored people. So by sheer this problem, we are essentially segregating the population between haves and have-nots. This is real data out of American Physics Institute. Now, if you look at a similar problem in India, students coming into the college come with different levels of preparedness. Some students are well prepared and others are not, and that's why you get the data of students being not ready for employment. The second problem is the cost of education. Again, in the US context, the cost of education is skyrocketing in the US. There's lot of discussion around this because the growth or rate of increase in cost of education is far faster than the rate of inflation. Okay, it's growing much faster. As a result of that, students are graduating with lots of debt. And as per US regulations, even if you file bankruptcy, you will not be, the student debt is never removed. So you will have to owe it no matter what. The worst case scenario is students who go into college, get a lot of debt, and never finish their degree. So they graduate without a degree, but with a lot of debt. I quote this from, Sarah Goldrick Rabb's research. She does pioneering work in the cost of education world. And I have in the next page a video of hers. So in the end, if I have some time, I'll show you a portion of her video. But at the moment, I'll move on to get to the rest of my presentation. Now, what is the India parallel to this? Consider those 94%, if that is true, of unemployable engineers who are graduating. Cost of education, engineering education in India is not cheap either anymore. So they are, obviously taking loans, spending their own money with the hope of getting a well-paying job. And if they're unemployable, then, there is a big letdown. What have they spent the money for? Where is the job? So there are critical parallels here. So that was two problems associated with the first zone, which is students coming into the system. The second one, which is the college zone, what is happening in the system, in the academia? Okay, in the academia again, we are structured in ways that was determined many decades ago. We are divided into distinct departments: electrical engineering, mechanical engineering, electronics, computer science, etc. We are having an education system which is highly based on prerequisites. So you have to finish course number X to get to course number Y, to get to course number Z, to course number alpha, etc. It is extremely overwhelmingly lecture based. So students are in a classroom listening to somebody talk for 50 minutes or 1.5 hours. And assessment is overwhelmingly exam based. So you take one exam or 3 exams or 2 exams. Most of the time it's major end of the semester exam. So that is the current structure. That is very efficient. That is very robust. It's very difficult to change this structure. But the questions to ask is this the right structure? Is this the right arrangement? Is this the right way of educating? Is this the right assessment? Is this the right assessment? And I'll show you a picture here. 2 classrooms, essentially very similar looking classrooms. There is, in the second one, it's also curved so that all the attention goes to the front. Okay, so these classrooms are designed so that knowledge will be flowing from one source to the rest of the classroom. That was the purpose of this classroom. We can clearly see that teaching is happening in this classroom. Can we say learning is happening in this classroom? The answer would be, I don't know. I don't know. Can we say, this boy who is sitting in this corner, with the white hat, with his, hand on his, or chin on his hand, is he actually learning? We don't know. Better yet, this large classroom of 200 plus students, are we sure all these students are learning? We don't know. We are sure that teaching is happening. Okay, so it's time has come to ask this question. These are difficult questions. Okay. The next thing that I come to is curriculum. We talked about all these interdisciplinary things, etc. But if you look at overwhelmingly, we are designed to be silos. Mechanical engineering is separate from electrical engineering, whereas in the last 20 years, the automobile, which is the key mechanical engineer's machine, in the last 20 years, all the innovation has been either in software or in controls, embedded controls, or in electronics. So in today's car, people cannot recognize what it looks like if you open the hood of the car. So why are we not creating programs which are a lot more interdisciplinary and breaking down barriers? Now, I will show you the next 2 slides. This is not meant to be a criticism. I've used the current undergraduate mechanical engineering curriculum from IIT Kharagpur, the 4-year courses. I picked it from the website. Uh, and I picked it only because of familiarity, because this looks very similar to the program that I teach in or any other mechanical engineering program. And I've highlighted some courses in yellow, and you'll see particularly in the second page and the first page, there's a lot of yellow. What does the highlight mean? These are the same courses that I was taking as an undergraduate student. Okay, the courses really, of course, their specific content may have changed, but these are the same title courses that I was taking. Now, again, as I said, this is not a criticism of any program. This is used for familiarity. But we got to ask the question, is this the best curriculum that we need right now? Is this the right curriculum we need right now? Okay. And after this, I'm going to show you the 8 areas that all people involved in Industry 4.0 claim that these are the most important things related to Industry 4.0. This is where all the innovation is happening related to Industry 4.0. And the question is, are we actually incorporating that in the current mechanical engineering curriculum? Okay, that's an important question to ask. Oops. Now, this question is not new. This has been asked to lots of faculty, and actually the answer to faculty is that everybody agrees that there needs to be a reform. Okay, but these are standard answers that people have given. One of them is, I can't do alone, everything. ABET won't allow me to do it. If ABET is the accrediting agency in the United States, accredits all programs, they have requirements. So in India also, there is a nationwide agency which kind of dictates what a standard engineering curriculum looks like. So people say, ABET doesn't allow me to do anything. This is the mechanical engineering curriculum, or this is the electrical engineering curriculum. A faculty will feel at a loss of grading reflection. Faculty are very good at grading, math-based problems. Engineering faculty are good and trained to do that. But when you have you have to grade other types of problems, faculty find it difficult. The most important thing, and this is a huge question to answer, is I agree that there needs to be some X, Y, Z stuff has to be added to the curriculum. But what do we take out? Okay, the curriculum is already full with lots of required courses. What do we take out? Okay, that is a very, very important question that we have to grapple with. And these are answers that came out of research. So I'm just throwing it out because these are the same answers that we would give ourselves when asked this question. And my answer to this is that fish don't know they are in the water. Okay, what does that mean? Okay, that means fish don't know. I mean, fish are only familiar with water. They have lived in water all their life. They don't know that there is a world outside water. They can't think of things, other than water that is ubiquitous. What I mean by this is that we are all products of this same system. We have all grown up in the same system. We think in terms of the same system. That is why it is difficult for us to think outside the system and think of a system that could be, or any system that could be any different from what we grew up in. Okay. So that brings me to the third part. Okay, that brings me to the third part of the work, which is the workplace zone. And here is a very interesting situation. The relationship between workplace as an industry and the academia is, I think worldwide is a very weird relationship. The workplace or industry actually employs the output or hires the output of the education system, but they have very little say over how the education system creates those outputs. Most of the time, it's in terms of suggestions, in terms of recommendation. Also, the involvement, forget the research involvement. That is, I think, well developed and well done. But in terms of the product output, as in students that they hire, it is a funny relationship, as in there is very little input from the industry that is actually considered and used to improve the student quality or improve the education system. So most of it in terms of suggestions. There is an opportunity here for better relationship or better involvement between the industry and the education place. So we ran some survey with lots of industry input, and there is more result, but I'm only showing, this part of it where they are recommending some of the things. And this is only out of this survey. There may be more things, and I'll read a few of these here. One of the things they say is improve collaboration with industry, including reform of the cooperative education development, increasing cross and transdisciplinary collaboration and integration of mechanical, electrical, industrial, and computer science, borrow from and incorporate concepts from the medical schools, like teaching hospitals to establish teaching factories. Okay? Very important suggestions. Very different suggestion. There is a profession which is doing things differently because people's lives depend on them. Improve the education of parents and prospective students, developing and improving and calibrating new set of dynamics and applications to integrate the physical, digital, and human domains into the educational experience. So essentially, they are saying in a way that, change the education system so it reflects the current times or the current needs. So with that, I've raised lots of questions and lots of issues, and I want to share in this last bit of my presentation some case studies. We'll go through them quickly. These are cases or places which are doing some of these things, and in research says they're doing that well. They're not doing everything that we have listed or we have tried to point to, but they're doing some of these things well. And these are the 5 places. Singapore University of Technology, University College London, Charles Sturt University in Australia, Technical University in Delft, Netherlands. And this is a brand new university in India, Plaksha University, which you may have heard about or are familiar with. So these are the 5 places. And I'll talk about 4 aspects. I've divided into, there's a lot more information on these places, but only 4 aspects. One is curriculum flexibility, interdisciplinary opportunity, pedagogy, and assessment. So in the Singapore University of Technology, they don't have our traditional disciplines like mechanical, electrical, computer science, etc. Their disciplines are architecture and sustainable design, engineering product development, engineering systems and design, and information system technology and design. Okay. So now you can get a sense of how interdisciplinary they are from the name of the program. It is much more of outcome driven than the discipline name driven. In terms of assessment, first of all, in terms of pedagogy, it is very design centered. It is very design centered. Active learning is the main methodology. Emphasis on hands-on learning, prototyping, collaboration, group discussion, problem solving. And the first semester is not graded. Thereafter, students take 2-3 exam. Most of the grading is continuous assessment of team projects constituting bulk of the grade. Okay. Let's move on to the next one, University College of London. Their curriculum is very similar to traditional curriculum. Same kinds of discipline as in mechanical, etc. But their pedagogy is very interesting. They have 5-week clusters, 4 weeks of theory and 1 week of practice. So they learn for 4 weeks in classrooms, and then they go and apply for the next week in actual problem solving. Around 40% of the curriculum is delivered through project-based experience. Okay. The third one is the Charles Sturt University. Theirs is a 5.5-year program, of which the first 1.5 years is on campus doing series of project-based challenges. So the first 5.5 years they're on campus. The next 4 years they're working full-time in industry. They're learning in the work-based environment. At the same time, they're also taking self-directed learning through technical engineering content that is delivered online in a tree-like structure. So, the tree-like structure refers to, so the tree-like structure in the child start refers to, instead of courses, they are divided into modules. Modules are topic areas or subtopic areas in the courses, and their requirement has to do with, X number of modules are required for you to finish the program. And those X number of modules are all over the place. So you can pick modules from different areas that fits in with your need for your workplace or what you need to learn. So it's more of just-in-time learning and learning what you need and applying it right away. Their assessment is also overwhelmingly based on projects and based on work that they are doing. Finally, Technical University of Delft, their things are much more traditional, but they have an extensive student-led extracurricular academic activities. So they do a lot of these, achieve a lot of these goals out of the classroom, out of the traditional classroom. So they are doing it very differently. So those are different models out there. And I am watching very interestingly with a lot of interest at Plaksha University, whose undergraduate program is about to start in 2021. They are physically going to be located in Chandigarh. They were started by 80 entrepreneurs in India who decided that they need a different university to be able to hire from the kind of students that they are looking for. Sorry, this part was on automated, so I have to go back. They have 4 majors: computer science and artificial intelligence, robotics and cyber physical systems, biological systems engineering, and data science, economics, and business. So you can see again the way they are trying to design an interdisciplinary program instead of going towards the traditional divisions of silos. And they are going to be very immersive and experiential, with flipped learning, online learning, and industry capstone projects. So I'm watching them with a lot of interest from a distance to see what happens. Now, in the case of Plaksha, they had the advantage of starting something from scratch. You can do a lot of things if you start something from scratch. The other 4 places were actually modifying their existing program. Some common characteristics about them are forward-thinking and adventurous leadership, forward-thinking and adventurous faculty, and forward-thinking and adventurous students. So you need all those 3 things in order to bring about change in any kind of education system. And with that, I will try to finish with some concluding statements. Technology is changing fast. The world of education needs to evolve. There is a lot of agreement around that. Education 4.0, there is general agreement in what the characteristics should be. The path is unclear, so I hope I'm leaving you with more questions than answers, because I'm looking for answers myself. Change will require a paradigm shift in the entire education ecosystem. I pointed out some of the main problems in different parts of the education ecosystem. These 5 places are, and there are others, have been successful in implementing some of the aspects, and we saw what those aspects are. And the question is, can we scale them? Can we import some of them? Can we learn from them and implement some of them? And finally, I leave with a favorite saying that I am saying these days a lot, which is we agree that students need to learn a lot of things. The question is, do we need to actually teach them all of that in 4 years? With that question, I'm going to stop here and acknowledge, 2 of my colleagues that I work very closely with, Drs. Daryl Klinke, who is an engineer faculty of my colleague, and Dr. David Pistrui, who is actually an economist and social scientist, but works a lot in the engineering field. They're my colleagues, and here are some of my references. And I'll stop here and see if you have any questions, discussions, thoughts, etc. I'm going to stop sharing the screen for the moment and turn on video. Thank you all for your attention, kind attention.
So thank you, Professor Das, for wonderful, the talk, and you have rightly pointed out the concern, and you have put all of us in in the deep thinking that what should we do for this for this reform in education. There are some questions from the audience as well, and what I can see is that it's Professor P.P. Date. It's mentioned that if rate of obsolescence is increasing exponentially, how does a student sustain his motivation when he knows that he wants to learn is going to be obsolete? What he wants to learn is going to be obsolete by the time he learns it.
That's an excellent.
The technologies are moving so fast, and how to tackle this situation?
That is an excellent question. That is the we call it the $64 million question. I'll give you my take on it. We have to learn how to teach lifelong learning, because there is no other way. Technology will be obsolete very quickly, so whatever we are learning will be obsolete. We are trained in a mindset that you learn for 4 years and you're an engineer, and then you sort of become an engineer and you don't have to learn anything. We have to change that mindset. I'm not talking about faculty members or research scholars who are continuously learning in their profession, but an engineer who is a 4-year graduate and then works. We have to, in fact, as educators, we have to think how to teach lifelong learning and teach it well, because that is the only thing that they will need, because everything else is going to be obsolete as soon as they learn.
The next question is even more the critical, that what is the purpose of building competence if I get to know that everything would be taken away by the automation?
Yes. That is I don't think, well, again, this is based on what I feel and what I have heard other experts say. I don't feel that everything is going to be taken by automation, because with automation, as you can see, with every step in automation, there are new opportunities, new work opportunities are being created, and opportunity or work is, some work is disappearing. So it is, again, it points to the fact that we have to continuously upgrade our skills or upgrade the capabilities of people. Otherwise, you'll be obsolete. And that points to lifelong learning again. So continuously changing of skills and upgrading of the skills is necessary.
Yeah. There is a question from Mr. Himanshu. He says that, sir, it's a very, very relevant presentation. There is a need to immediately adopt this and keep correcting down the road. Indo-German tool room or Danish tool rooms are interesting case in point, given the popularity and usability of the graduates in the industry. Okay, so it's a suggestion sort of thing. One question from Shloka Jaiswal: can MSMEs approach IITs to request solutions to some of their problems around the manufacturing process? Can they be approached through FOSME or directly? I hope this would be a great learning experience for both the students and the firm. I think this question is directly to Center of Excellence in Advanced Manufacturing. Yes, I would like to answer. Yes, the MSMEs can approach us directly or through FOSME or through CII, the BCCI, MCCI. You can write to me directly at the CoEAMT email ID. And we are giving training to the MSMEs, startups on different topics. We are also organizing the short-term courses, or they're conducting the workshops as well, and we are working for the industrial, the research problems. So you are most welcome, and we'll be happy to serve you. Professor Farooq Mistry has commented that it's an outstanding talk, many lessons for faculty at IIT Kharagpur. Suggest a conversation on this topic. That's what Professor Farooq Mistry has.
Well, thank you, sir. for the acknowledgement and a wonderful suggestion. One of my purposes of giving this presentation is to, as I said in the beginning, raise questions and invite discussions, because I'm asking these questions myself. I'm asking with my colleagues, and we are looking for answers, good answers. So I would be very, very interested in thoughts around the world, thoughts at IIT Kharagpur, and very, very interested in participating in more of discussions, deeper discussions around individual aspects of it.
There is a comment by Professor Alok Kanti Dev of Electrical Engineering Department of IIT Kharagpur. Professor Dev, can you just, because this question is not complete, so can you just unmute yourself and pose the question? Professor Dev, he has mentioned that embedded controls and software MTech program in Advanced Technology Development Center at IIT Kharagpur. Yeah, so I think he wanted to mean that we do have the the interdisciplinary or the transdisciplinary the programs, because which you have mentioned that the education 4.0 must have the transdisciplinary programs, flexible curriculum, and industry academia collaborative platform. So,
Professor, I actually wanted to mean that we, in that curriculum, in IIT Kharagpur,
yeah,
we take students from irrespective of the background, electrical, electronics, science, even mechanical students were also there in this PG curriculum, and it was actually opened as per industry requirement. So when Professor Das was mentioning about the interdisciplinary thing, I thought to mention about that course.
Did you say it is a PG curriculum?
It is an MTech curriculum, yeah, PG level. Yeah.
Okay. Just to clarify, yeah, I think Professor Mistry has a question.
yes, sir, please.
He may be on mute. Sir, you're on mute.
Professor Mistry, please unmute yourself. I think some problem is Professor Mistry has also given a YouTube link.
So let me tell you, I saw the questionnaire that was circulated to IIT faculty on education. And the focus there was totally on technical competencies. What Professor Das out here has put together and made us aware of are the non-technical competencies that are needed for the students to have lifelong career-sustaining skills. So I think the questionnaire that was sent out was well motivated, but it asked totally the wrong questions. Totally the wrong questions. What needs to be done is to have a questionnaire along the lines of what Professor Das is talking about and what I believe in. So what you may like to do is to engage Professor Das in putting together a questionnaire to the faculty in terms of whether education and how it needs to be done. This is not something that, this is a very serious issue, because anytime I talk to people at IIT Kharagpur, they say we'll put another course in on technical this or technical that. We need to be broader than that. And what Professor Das has done out here is absolutely phenomenal. And this is what is needed for us to rise in the rankings.
That this is a worldwide problem, or I won't say problem, a phenomenon, that when we are told, hey, these are the 5 things that need to be taught, we think of how to push more technical content in the curriculum. And we have done that in our programs in all the time, and asking, as you just said, asking the wrong questions. Given that most of the things will become obsolete, why are we pushing so much of that, and rather than building the skills necessary to be successful in their careers?
So one point from Professor Mr. Subir Majumdar, the excellent presentation One issue arises from the layoffs of people being displaced by automation and process improvement. This leads to frustration and social problems. The industry tends to just lay the workers off without caring about retraining of the displaced workers. So that is a comment.
Yeah. That's a very good point. I mean, this is something that happens worldwide. This is not just a situation in India, because the industry their goal is to making profit, and that's their bottom line. So they are going to go and look for workers who can help them immediately, and that's how they operate. But industry has to be engaged in a way that the academia can help retrain these workers. But that all goes down to a change in mindset, in my opinion, because in the current education system, students finishing 4-year degrees are coming out with a mindset which does not require them to be lifelong learners. They come out with the mindset, oh, mujhe degree mil gaya hai, now I will use this piece of paper and get jobs. That mindset is a result of our system.
Yeah, you are absolutely right. Is there any other question? Anybody? I think I have read out all the questions that has been kept in the chat box. But if you have got it, yeah, Mr. Devajyoti Banerjee has written, it is refreshing to see that you are emphasizing soft skills development in our engineering curriculum, along with the traditional hard skills. Can participation in sports, particularly team sports, become part of the curriculum?
Yeah, I mean, the teamwork. I mean, in the US, there is a lot of emphasis in engineering to improve teamwork skills amongst engineers. So we purposely put our students in a lot of team projects, but just putting them in teams doesn't necessarily mean that they will actually be good at teamwork, because personalities don't necessarily go very well in teamwork. Like, if their students have different personalities and there is clash, there is difficulty in teamwork, and there is a whole class of literature and practice that has developed around managing of teams well. Okay, there is a process of, even with difficult personalities, you can manage the team well to get the right output. That has to do with project management and learning the skills of it. Now, as a student, we don't teach them normally in a classroom with all those skills, but those are some of the first skills that they need to use when they go into the workplace. And they, how to work with other people, how to work with difficult personalities, how to work in teams, and still, even if you don't get along, still make the project successful. So those are very, very important skills that are necessary for the students that, we don't do a good job and focus on them.
Good. Yeah. Is there any other questions from the audience? If not, then, so Professor Das, it was a wonderful, the lecture. We are really grateful to you for your presence, for your lecture. And Center of Excellence would like to thank you for this, the particular, the eye-opening lecture and all. I would like to thank all the audience for their presence, and I look forward to their presence in the coming Saturdays as well. Our next week, the webinar would be from Professor Kailash C. Kapoor of University of Washington. Professor Kapoor would be, talking about the quality control in manufacturing. So what are the activities past, present, and then future? Then the next one would be from Professor Subir Kumar Saha of the IIT Delhi. Professor Saha will talk about why robotics to cobotics. And next, on May 2022, would be the Mr. Suresh Adina on the AR gear in manufacturing. And the last Saturday in the month of May would be from Professor Shreyas Melkote of Georgia Institute of Technology on the robotics. With this, we'll be finished all the webinars in the month of May, and the June month also it is getting scheduled. So as soon as it comes up with us, we'll let you know. With this, I'd like to thank once again to all of you for your presence, and I look forward to your participation.